Hello students, I hope that you are good, well and fine. Okay, so as we saw in just previous session about the applications of integral, and in that we saw area under the curves. Okay, now we are at the miscellaneous examples, and then we will be seeing miscellaneous exercise problems also, and then the chapter will be ended. Okay, so let's see the first example of a miscellaneous example. Okay, so we have to find the area of the region bounded by y is equals to 3x plus 2, which is a line. Okay, and the x-axis and the ordinates x is equals to -1 to x is equals to 1. Clear? So first of all, graph it. Okay, so that you have some idea what will happen. So your graph looks like this, or y is equals to 3x plus 2 will be your line like this. Now what you want, your area from -1, as you can see, x is equals to -1 to 1. This means these three areas you want. Okay, first one, second one and third one. For this which is from -2/3 to 1, you will get your area directly without any problem. But for this part, -1 to -2/3, you have to apply the modulus sign. You have to apply your modulus sign. So first is -1 to -2/3 integral 3x plus 2 dx will be what? As it is your under the x-axis, your graph is under the x-axis. This means you have to apply a modulus sign here. Clear? Now plus this is above the x-axis, so no need of applying modulus sign. So you will get integration -2/3 to 1 3x plus 2 dx. Simple. I hope it is clear to you. So whenever you have your graph above the x-axis, no need to apply any modulus. Whenever you have your graph under the x-axis and you have to find the area, then you must apply your modulus there. Okay, now you know that x is going from -1 to 1. Okay, but how you found out this -2/3, 0, this coordinate? Very simple. This is what, where y coordinate is 0. Let's see where y coordinate will be 0. Just apply y is equals to 0. This means 3x plus 2 will be 0. This means 3x will be -2. This means x will be -2/3. Okay, so your point will be what? -2/3, 0. By this approach, you can find this intersection point. Clear? Now you can directly separate your integrals into two parts, which is area of region ACBA and area of region ADEA. Add them, you will get your answer. So for area of ACBA, you know ACBA will be, as you can see, this is under the x-axis. This means you have to apply what thing? You have to apply your modulus sign here. Okay, clear? Okay, so after applying the modulus sign and after doing the integration, you will get 1/6 plus 25/6. This means 13/3 will be your answer for this. This means 13/3 square units will be the required region area for the region. Clear? Okay, now next example. Area bounded by the curve y is equals to cos x from x0 to 2 pi. So first of all, draw the graph of cos x from 0 to 2 pi in this interval. So 0 to 2 pi interval, you will have this. You want area. Okay, area bounded by this curve from x0 to 2 pi, also the x-axis. Okay, so first area will be this, second will be this, third will be this. So area for OABO, if you see OABO area, this, and this is above the x-axis. This means this no need to apply any kind of absolute value. Now BCDB, this area is under the x-axis. This means we must apply our modulus sign here. DEFD, DEFD, no need to apply modulus. Okay, now limits will be for this OABO. For this limits will be what? 0 to pi by 2. For this BCDB, limits will be pi by 2 to 3 pi by 2, and for DEFD, limits will be 3 pi by 2 to 2 pi. Okay, so 0 to pi cos x dx plus modulus of pi by 2 to 3 pi cos x dx plus limits will be 3 pi by 2 to 2 pi cos x dx. This means that you know the direct integrals. Sin x 0 to pi by 2, modulus of sin x, limits pi by 2 to 3 pi by 2, sin x 3 pi by 2 to 2 pi. Just evaluate it, you will get your answer as 4. So the required area will be 4 square units. Okay, I hope it is clear how we are applying our under the x-axis and above the x-axis concept here in order to find our area. Now miscellaneous exercise on this chapter 8, or this will be the end for this chapter. Okay, so how many problems we will be having in this? So only 5 problems. So let me just quickly show you the solutions. Okay, so find the area under the curve, okay, and given lines. Y is equals to x square, x is equals to 1, x is equals to t, and x is equals to 2, and x is equals to and the x-axis. Okay, just quickly draw the graph. This means x is equals to 1 to 2. This area you have to find ABCD. Okay, ABCD, or in other words, whatever the name you want to give, ADCBA. Okay, this closed region. So quite simple. The limits will be what? From where to where? 1 to 2. Y dx. Y will be what? X power 4. So x power 2. For first part it is x power 2. So x power 2 dx. 1 to 2 limits. So quite simple. X cube by 3. 1 to 2. You will have 8 by 3 minus 1 by 3 is equals to 7 by 3. 7 by 3 square units will be your final answer for this required region. Okay, I hope it is clear. Okay, now what about the second? So x power 4, y is equals to x power 4 graph will be like this. Okay, the limits will be from x1 to 5. The area for will be, the region will be ADCBA. Limits going from 1 to 5. So 1 to 5 x power 4 dx. Integration will be x power 5 divided by 5, limits 1 to 5. This means 5 power 5 divided by 5 minus 1 power 5 divided by 5. This means 5 power 4 minus 1 by 5. This means 625 minus 1 by 5. This means 624.8 units, square units. Okay, this will be your required area. Simple, very easy questions. Okay, so if you are finding them quite difficult, so don't worry, you just have to practice more. Okay, the only thing you are hesitating or you are not getting your answer is that either you are getting scared, okay, or just you didn't practiced, okay, enough. Clear? Now second, sketch the graph. So first of all sketch it and then evaluate this. So we have to evaluate this thing. So a sketch for this will be like V. Okay, the modulus graphs looks like V. Okay, it will be shifted toward left, and the vertex will be the corner. The vertex will be at point the coordinate minus 3, 0. Okay, as you can see, minus 3, 0. Clear? This will be your graph. Okay, now you have to evaluate, which is, as you can see, so from minus 6 to 0, you are getting from minus 6 to 0. If you try to see minus 6 to 0, this means this region. Okay, minus 6 to 0 and the curve given, which is minus 6 to 0. This means if you try to interpret it in terms of area, what you have to evaluate is area under the curve or area enclosed by the region x-axis. X is equals to minus 6 to x is equals to 0. That's it. Okay, so these two reasons you will have. This means you have to break it into two parts, which is one -6 to -3, as you can see, -6 to -3, and another will be -3 to 0, -3 to 0. Clear? I hope it is clear to you. And in this interval -6 to -3, your x plus 3 will be negative. This means modulus will be negative of x plus 3, and in this interval it will be positive. This means just positive. Just integrate it. Keep the points in your mind that this minus sign is there. Okay, apply the second fundamental theorem of calculus of okay, so you will get what as your answer as 9. So after evaluating this, you will have 9 as your answer. Or you can also say that area under the curve, this curve given from 0 to -6 to 0, you will have the area of 9 square units. Clear? I hope it is clear to you. Okay, so far so good. So now problem 3. Problem 3 says find the area bounded by y equals to sin x from 0 to 2 pi. This means first of all you have to draw the graph for sin equals to x. In what interval? From 0 to 2 pi interval. So you all know the graph, which is like this. This means you have to find this area OABO and this area BCDB, this two area, and you know this OABO area is above the x-axis. This means positive. This BCDB area is under the x-axis. Here we must have to apply our modulus thing. Okay, so limits will be for OABO, limits will be 0 to pi, and for BCDB limits will be pi to 2 pi, as you can see. Okay, this means 0 to pi and pi to 2 pi. This is under the curve. This means apply a modulus sign here. So we applied. This evaluation is very simple. Minus cos x, limit 0 to 2 pi. This is same. Modulus, inside modulus you will have minus cos x pi to 2 pi. Now apply the theorem, respective theorems. You will get your final answer as 1 plus 1 plus modulus of -1 minus 1. This means 2 plus minus modulus of -2. This means 2 plus 2 is equals to 4 square units will be your required area. Okay, under the curve, or area bounded by the curve y is equals to sin x, and from 0 to 2 pi on x-axis. Clear? I hope it is clear to you. Very simple things we are doing. Okay, now fourth problem. So area bounded by the curve y is equals to x cube, and the x-axis, the ordinates -2 to 1. So let's see the first of all the diagram. Diagram will be for x cube is like this. Now as you can see, from x is equals to -2 to 1, you will get two areas, which is one is OCDO, another will be OABO. Okay, OCDO area is under the x-axis. This means we have to apply the modulus sign here, and in OABO is above the x-axis, so no need to apply modulus here. So limits will be for OCDO. What will be the limits? Limits will be the -2 to 0, and for OABO limits will be 0 to 1. Okay, as you can see. Okay, so what you will have, you will get 17/4 as your answer. Simple. So do it by your own. This will give you what? The exposure to solve your question. Okay, that how we will approach it. The main things I have already told you. Okay, so solve it by yourself. Clear? I have already told you the parts, that in two parts you have to divide your integration. In first part, which is under the x-axis, you must apply your absolute or the modulus thing, and in second part no need to apply a modulus thing. The first part, the limits will be -2 to 0, and in second part it will be 0 to 1. Clear? Now the fifth. Okay, so please do try it by yourself, and the correct, you must get your D as your answer, which is 17/4 square units. Okay, now fifth problem. find the area bounded by this curve. Okay, x-axis and the ordinates x is equals to -1 to 1. Okay, hint we have already given. If x is positive, your graph will be x square, and if x is negative, your graph will be minus x square. So x is positive, your graph is like x square. Clear? If x is positive, as you can see, if x is positive, your graph will be of what? X square. And if y is positive, your graph will be what? Okay, clear? Okay, as you can see, it is already given here. Now what is happening? Okay, what is happening here is that, okay, so now the required area will be what? As you know, the limits will be from -1 to 1 y dx. Y will be what? This x modulus x. You know, we have to break our limits or our integration into two parts, which is -1 to 0 and 0 to 1. Why? As it is behaving into two different ways. In -1 to 0, okay, x is negative. This means you will get what? Minus x square. And here you will get what? Your x as positive. This means you will get x square, just x square. Clear? And in this, okay, in this integral, definite integral, the value will be x cube by 3, limit 0 to 1. This means 1 by 3. Okay, and in this you will get the same thing. The minus sign is there. Okay, so that little typo error here, so not written over here, but it is written over here. Okay, so do not confuse from where we got this minus sign. Okay, there is a minus sign here. Okay, why? I have already told you, because of this -1 to 0 interval, this modulus is minus x. This modulus x will be minus x, so that's why minus x square must be there. So you will have minus of x cube by 3, limits -1 to 0, so it will become 1 by 3. So your final answer will be 2 by 3 units. Clear? I hope it is clear to you. Okay. Now let me just quickly summarize the things for you. So what we have seen that the area of the region bounded by the curve y is equals to fx and x-axis and the lines x is equals to a and x is equals to b, where b is greater than a, is given by the formula area is equals to definite integral a to b y dx is equals to definite integral a to b, where y is in terms of x, fx dx. Okay, the region bounded by the curve x is equals to phi by now y-axis and the line y is equals to c and y is equals to d. Then the area will be definite integral c to d x dy, which is x must be in terms of y as phi y. Okay, so integration c to d phi y dy. Okay, I hope it is clear to you. So you can also refer this historical notes if you want to know that from where it originated, who originated this integral calculus thing. Okay, who developed it further. Okay, clear? You can also refer it. Okay, I am leaving this whole history for your curiosity. Okay, please read it. Okay, you will get your curiosity and you will clear? I hope it is clear to you. Okay, so this is it for our side from this chapter, applications of integrals. Okay, I hope that you understood every explanation. Clear? So we will be back with the next chapter, the chapter 9. Okay, and that's it from this chapter. Please practice more, practice lots and lots of problems. The first and the foremost thing is to do the NCERT exercise and then the exemplar problems. Okay, if we have enough time, then we will definitely be discussing about, okay, or we'll be providing you the sessions on exemplar problems also. Okay, it's totally depends on the time. Okay, so I hope that you must keep all these points in your mind. Okay, and also from the perspective of exams and competitive exams, or also the board exams, you must know the formulas. Okay, and this integral calculus concept very well. Why? As it is one of the major part which is asked in various exams. Okay, so this is it. So thank you.